Hello, Math 2 students. The big quiz is on Thursday. Factoring. Do you know how to do it, and can you do it on a quiz? Well, today we had a practice quiz, and I've identified 4 problems that gave many students difficulties. We're going to go over those 4 problems now. The first problem that we're going to look at is a problem where it's not easy to factor. You just have to look and see if there's a way to find numbers that multiply to your first term and numbers that multiply to your last term. So what we're looking at right now, number 1, if there's some prime numbers, that makes it easier because they only have 2 factors. If we're going to have to guess on a number, let's guess with the factors that are closer together on the number line. And let's make sure that we don't put 2 things into the same binomial that have the greatest common factor. So this is problem number 4 from the practice quiz. Negative 21x squared plus 2x plus 5. And one of the tricks of this problem is they have it already set up to fill in the answers into blank answer binomials. And they already put the signs in the blank answer binomials. So you can't change those signs. You have to make sure when you find your answer that you can fit it into their template and put your answer into their blanks, which I think probably caused some people some problems. So anytime they ask us to factor, we have to start by trying to take out the greatest common factor. And so when I think of 21 and 2 and 8, I can't think of a number that goes into all 3 of them evenly except for 1. I do notice, though, that my a value, which is negative 21, is negative. And we never want to have an a value that's negative. So my very first step on this problem will be to take out a greatest common factor of negative 1. Now I need to find out what is the remaining polynomial after I take out my negative 1. So I'm going to divide each of those 3 monomials by negative 1. So negative 21x squared divided by negative 1 is positive 21x squared. Positive 2x divided by negative 1 is negative 2x. And positive 8 divided by negative 1 is negative 8. So my remaining trinomial is 21x squared minus 2x minus 8. So if 21 was a prime number, that would be great, but it's not. 21 is either 1 times 21 or 7 times 3. And if 8 was a prime number, that would be great, but it's not. It's either 1 times 8 or 2 times 4. So when I go to find my binomial factors, I'm going to have to do a bit of guessing. But I'm going to start out by using the factors that are closest together on a number line. So 7 and 3 are closer together than 1 and 21 are. So I just have a feeling that 7 and 3 might be a better bet. So I'm going to put a 7x here, and I'm going to put a 3x here. Now, for the 8, I could use 1 and 8, or I could use 2 and 4. But again, 2 and 4 are closer together on a number line than 1 and 8, and I found that that can get you going in the right direction. So I'm going to guess those. But this is a guess, so I might have to change things up. Now, one last thing. I know that my C value is negative 8, so my signs are going to be different. So I'm going to put a plus in front of the 2 and a minus in front of the 4. Now, the only way that I can tell if I'm right or not is to check by foiling. So I'm going to go FOIL, and when I multiply my first, that's 7x times 3x, that's 21x squared, which makes sense because we picked 7 and 3 because they multiply to 21. And then we have our lasts are going to be negative 8, and that also makes sense because we picked 2 and 4 because it multiplies to 8. So the part we're really checking is the outers and the inners. So the outer terms are 7x and negative 4. That makes negative 28x. Our inner terms are 2 and 3x. That makes 6x. So when we put our outer terms and inner terms together, we're going to have negative 22x. That is not the answer that we're looking for. So what I'm going to do now, I'm still going to stick with 7 and 3. I'm still going to stick with 4 and 2, but I'm going to switch the location of the 4 and 2. Okay, so I know already that my firsts are going to be right. That's 21x squared. I know that my lasts are going to be right. That's -8. But what we're looking for is the outers, 7x times -2, which is -14x, and our inners, 4 times 3, which is 12x. And when we put those together, that will give us a -2x. And that is exactly what we're looking for because our middle term of our trinomial is -2x. So now we have the answer. We need to put our answer into the Big Ideas Math template for the answer. So the first set of parentheses has a plus sign in between. So I'm going to put my 7x plus 4 there. And the second set of parentheses has a minus sign. So I'm going to put 3x minus 2, except I don't need the minus sign, 3x minus 2. And notice that my greatest common factor, -1, is already out there. So that would be the right answer to this problem. The rest of the problems that gave people difficulty had to do with the shortcut patterns that you're supposed to be memorizing. So the first shortcut pattern is the difference of two squares. It turns out that this was not one of the problems that people had, but I think there's always confusion between the difference of two squares and perfect square trinomials. So the difference of two squares is always a binomial. The difference of two squares is a binomial, and when you factor it, you end up with a sum and difference pattern. So you start with two terms and you end with two binomials. A perfect square trinomial works the other way around. You start off with a trinomial, and when you're done, because of the fact that both binomials are the same and you write it as a binomial squared, you start with a trinomial, but you end with only one binomial squared. So you need to memorize that so that you don't get those two things confused. So on the first problem, it just wants us to identify each expression that can be factored using perfect square trinomial pattern. So they want to know which of these polynomials is a perfect square trinomial. And so when we look at them and we think of the list that we were just looking at, this is what we're looking for. They are trinomials, yes. Every single one of these has an a value that's a perfect square. There's a 1 in front of the n, there's a 1 in front of the x, there's a 1 in front of the m, and there's a 4 in front of the d. So all of the a values are perfect squares. Now if we look at the constant terms, we have a 4, which is a perfect square, a 9, which is a perfect square, a 16, which is a perfect square. So all of them have a values that are perfect squares and c values that are perfect squares, and they're all trinomials. So the only other thing you have to check for is their c value. Is it positive? And yes, all of them have positive c values. So at first glance, some people thought that all of these were perfect square trinomials. But when you take a closer look, it's easy to see that they are not. So here we go. If it's a perfect square trinomial, then it will have a binomial squared for its factored form answer. So that means both of our binomials are exactly the same. And the sign will match the sign of our b value. So on this problem, it's going to be n and 2 and 2, and our b value is positive. On the next problem, it will be 2d and 2d and 3 and 3, and our b value is positive 12d. On the problem with the x's, we'll have x and 4 and 4, and our b value is -8, so those are going to be negative. And finally, it's going to be m and 4 and 4, and our b value is just positive m, so our signs are going to be positive. Now, the problem is not all of these, if you check them, are going to work out. So you have to quickly FOIL each one to see if it's going to work. So it might have been confusing that you thought that this will work every time, even if you don't check it, but you still have to check it. It just doesn't, you don't have to guess so much at the beginning, but you still have to check to make sure that you're right. So if we check by foiling, on this problem, they want us to find the solutions to the equation 9x to the third minus 48x squared equals negative 64x. This problem needs to be put into standard form. So I'm going to add 64x to both sides, and when I do that, I will have 9x to the third minus 48x squared plus 64x equals 0. Now, I need to take out the greatest common factor, if I can, before I put it into factored form. In this problem, I can't think of a number that goes into 9 and 48 and 64 evenly. So I think my greatest common factor is an x, because I see that every term has at least one x. So I'm going to put my greatest common factor in front as an x, and then I'm going to divide every term by 1x, and I'm going to get my remaining trinomial. So that will be 9x squared, that will be negative 48x, and this will be positive 64. So now I notice something right away about my remaining trinomial. When I look at it, it's a trinomial. My a value is a perfect square. My c value is a perfect square. My c value is positive. So there's a good chance that this is a perfect square trinomial. So I'm going to attack it like it is a perfect square trinomial and then check my answer. So I have x, and here are my binomial factors. And to get 9x squared, I know I'm going to use 3x and 3x, because if it's a perfect square binomial, both of your binomial factors will be the same. So to get 64, I'm going to use 8 and 8. And since my b value is negative 48, both signs are going to be negative. So that might be my factored form answer. I'm going to quickly FOIL. So now I know that it was a perfect square trinomial because both of its factors came out to the same thing. So this is a problem where they're asking me to solve. So I'm going to have to use the zero product property. So I'm going to write down my equation again, and I have an x in the front, so I know that one of my solutions will be x equals 0. And then this has a coefficient in front of the x, so in order to solve for x, I'm going to have to solve this equation. So I add 8 to each side, and I get 3x equals 8, and I divide by 3, and x equals 8 over 3. So I have one solution of 0 and two solutions of 8 over 3. So that's sometimes called a double root. All right, finally, exercise 9. When you factor a perfect square trinomial, which pattern results? A difference of two squares, a square of a binomial pattern, or the sum and difference pattern. So we're talking about a perfect square trinomial. A perfect square trinomial. When you factor it, it is a binomial squared pattern. So the answer to this problem, when you factor a perfect square trinomial, which pattern results? It's a square of a binomial pattern. This would be the right answer. All right, Math 2 students, we're done, but I truly hope that this is helping you understand better how to factor and solve by factoring. So I have one last thing to tell you. Tomorrow is Wednesday. It's a no Zoom day. But if you have time, I want to invite you at 1:30 p.m. in the afternoon to come to office hours. And between 1:30 and 2, I will just be putting up practice problems and helping you with the answers. So if you want to study for the quiz, and the best way to study for a math test is by doing practice problems, come to office hours tomorrow at 1:30, and between 1:30 and 2, we will be doing a math workout to make sure that we are mathematically fit for the quiz on Thursday. See you then.